So to begin with, I'm pleased to have as our first presenter, Ms. Lisa Miller, C.E.T, Lisa is an associate with Lieber Rubish Incorporated, thank you very much, a firm that provides specialized services in fire protection and building code consulting. She has 9 years of experience in building code consulting, fire protecting engineering, and has led numerous complex building projects from small and large apartment complexes to new hospitals. Lisa is a graduate of Conestoga College's Architectural Construction Engineering Technology Co-op program and has been certified engineering technologist since 2006.
Good morning, everyone. I hope you're all enjoying the conference so far. Some brief background on the Diefenbunker. It was constructed between 1959 and 1961. Its purpose was to maintain critical functions of the government of Canada in the event of a nuclear attack. The design of the bunker was that of a nuclear attack. There was limited ways in and less ways out. It wasn't intended that people were going to be leaving the bunker. Eventually, there was no more use for the bunker, and the bunker closed. Ultimately, it was the end of the Cold War, changes in technology, and government cutbacks. I thought the animations were out. I apologize. I guess we're waiting for the photos. But in 1998, the Diefenbunker was opened as a museum. So it has been sitting there in operation for 14 years as a museum. There's a few pictures. I'm sure some of you have seen the poster. We've got some construction pictures out there. And the one on the top right, I believe, is the Bank of Canada vault door that we can't get to right now. It's down at the bottom level. It's not accessible. The project originally was limited when they opened as a museum to 60 people, and that was due to having one way out of the bunker. The building code requires that buildings have at least 2 ways off of a floor, and in many times, the bigger the building, you'll need many more ways off the floor. As a bunker, this didn't work very well. Every time you punched a hole through the outside, it was a weak point. So there was, as I was saying before, there was one hole at the main entrance on level 400 and a very large blast tunnel that led left and right from that one entrance to protect that entrance in the event of an attack. The bunker does have 2 emergency escape hatches, but those weren't viable exits from a code perspective in that they're filled with, I think it's around 30 feet of gravel vertically, and there's a diameter of 2 or 3 feet deep. And that was to protect the bunker below from a nuclear attack outside. So you would go in and open the chute, the gravel falls through, it goes through a pit, and you climb up a ladder. So that's okay as a bunker, but as a museum to which the general public is admitted, that's an awfully complicated and dangerous method of escape if there's a fire in the bunker. So as a museum operation, 60 people is difficult. The Diefenbunker was turning people away because they had reached their capacity and they were not able to maintain that on a long term. So ultimately our project, I'm sure some of you are aware, there was not a lot of construction required. In 2003, the process started. They said, we can't continue to operate with 60 people. We need to find some solutions. And so some of the initial firms that they had talked to had come back with, a variety of options and solutions, but many of them were cost prohibitive for a museum. I'm sure we all know that they're also often not for profit. In 2005, the partnership between LRI, being my firm, and the Diefenbunker began. They called us, they said, we have this problem, can you help us? And that's a large part of what we do as technologists in my firm is solve unique problems. We have a very thorough understanding of the building code, and we can consider alternate ways of applying the building code. So in May of 2005, we submitted a preliminary report to the authorities to see if they'd be willing to continue talking to us to find another solution, because the option of building another stair was not feasible. The bunker, the top and bottom floor are 5 feet thick. The rebar is huge. The walls and the intermediate floors are 2.5 feet thick. It takes 3 days to drill a little tiny conduit hole through the concrete. We can't punch through it. We have to deal with what we have. We have to work with it. Ultimately, the negotiation process completed in May of 2008 when they approved our alternative solution. And it was tendered in '09, and the project was completed in June of 2010. It's sitting there today as a museum, and I was very pleased to see they have many buses coming in now. They've got lots of people. So I'll go through the process and the upgrades for the project. So what resources did we use? The authorities had toured the site and indicated that they would be willing to consider a higher occupant load. So the resources that we had at our disposal now was the Ontario Building Code. The 1997 Building Code, which was the last building code issued prior to the '06 one, was prescriptive in nature. It gave you the requirements and it told you how to do it. There was generally one way to do it. Building codes are supposed to be issued every 5 years, but the next code that followed the 97 was the '06. They were waiting for the national to be issued in '05 because we've moved into an objective-based codes. So with the objective-based codes, we now had intent statements, functions, and objective statements that we could try to achieve where we could not achieve the prescriptive requirements. And in the case of the Diefenbunker, the prescriptive requirement was 2 exits. So each exit had to lead independently to grade from the building without going back into the building or into any other shared path. So objective-based codes are intended to provide a number of benefits. The important ones on this slide as they pertain to the Diefenbunker, in my opinion, is an increased understanding of the reasons for the code provisions. That makes our negotiations with the authorities that much easier because we all know that the intent that we're trying to solve as opposed to just trying to put in 2 exits. Second to that, there's an increased flexibility with this process, especially when there's existing buildings that have construction difficulties. I don't think there was any argument in that we really did have construction difficulties in getting other exits out of this building. It is fair to note that many international countries have already moved into an objective-based format. Australia and Ireland certainly come to mind, and fire engineering is certainly a lot more common there, where we are doing more design work and problem solving and using computers and modeling and doing a number of calculations. And the industry is not that new anymore, but very small and certainly evolving. So it's a very exciting time for us right now. Since the objective-based codes provide greater flexibility to existing buildings and provides the intent to achieve for the Diefenbunker alternative solution, that's the path we looked and looked at that one. So why would we propose an alternative solution? To allow an innovative solution. Who proposes them? The design community does. The authorities are not allowed to propose them. They are there in a review and a regulatory process. So we may work together in that we'll bring in ideas, they'll review them, they'll think about them, they'll bring us their feedback, they'll tell us what they like and what they don't like, and that process can take some time. Just a brief slide in terms of the code overview. As I was mentioning, the 97 and the '06 code had some significant changes. One of those, to say the least, is that it doubled in size. It was already a 3-inch binder that was very heavy and cumbersome. Now it's 2 3.5-inch binders to get all of that material out to the design community for all of us to use. So there's Volume 1 and Volume 2. Volume 1 is where I spend most of my time, specifically Division B, which has the acceptable solutions, which would be the prescriptive code requirements that we all know in the construction and building industry from years past. In Division A, that is where it provides the objectives and the functional statements for us to evaluate alternative solutions. This is one page from a very comprehensive report on the Diefenbunker project that we used to negotiate with the authorities to find a solution, to solve the problem. The problem being, we want more than 60 people in here. Their original target was 500. They wanted to go from 60 to 500 people. That's a lot of people to manage in a fire emergency. So I'm not going to go through the whole thing, but I will tell you some of the background in terms of getting to this one little page that took us 3 years of work. The solution included passive and active fire suppression, that I'll go through some more, detection, containment, and cumulative exiting. So it was a number of factors together that provided the solution to the authorities. In terms of the background of the Diefenbunker, it's the largest one in Canada. I think there was approximately 6 built, don't quote me on that, it's in and around there. They were scattered across Canada. The Diefenbunker was certainly the largest one. It was 4 stories, many of them were only 2. It was originally intended to support 525 occupants for 30 days. The floor plate, somebody was asking me earlier, is 2,350 square meters. It's a box. Each floor is the same. Each floor has 3 fire-separated exits, but none of them go anywhere except off of a floor. One exit will lead into the tunnel at the front. So in terms of the project upgrades as part of the solution, one of them was the fire separation. So of the first part of the list, number 1 was containment. Each floor has 5 fire zones. Originally, I understand that they were built, or they had intended to build them to be a 3-hour fire compartment. So if a fire started in one compartment, the compartment would close with the intention of containing the fire so that it did not spread horizontally through the building and vertically through the building. In order to do this, we repaired existing corridors. Over the years, with a lot of penetrations, the interior corridors are easier to punch through. So we would punch through, they had punched through them with services and other intranet and other facilities and infrastructure in order to use the building. So we upgraded the walls. We had to do some testing. We took some wall samples. We took them to ULC laboratories. We had them tested to understand what the fire rating was. Some of them had an acceptable level of rating at an hour. Some of them needed to be upgraded and have a little bit more fire rating provided so that they would have a higher level of containment. The existing entrance tunnel, I'll come back to this one on another slide, was separated into 2 means of egress so that there was 2 paths, one protected from the other one. And the exit stairs within the facility, which would be the vertical evacuation from a floor, even getting off of a fire floor and to another floor is another level of safety in horizontal and vertical evacuation. And so we had evaluated those stairs and the doors and made sure that the doors were latching and self-closing. So all of this is happening in the background. It's a passive system and it's just there and expected to work. So this drawing is showing, it's also on the poster outside, and this drawing is level 400 at the top. It's the highest level. All 4 levels are approximately the same. In layout, it's a very cylinder with inside just moving around in a circle. So this being the highest level, the 2 red corridors that are on the left and right side of the screen are showing the improvements in the corridors where we increase the rating to maintain a protection level from the 2 stairs at the back of the bunker to pull them forward towards the single way out. Because again, there's only one way out. We can't cut through 5 feet of concrete and take the stairs straight up. There was also some heritage and aesthetic requirements in that they still wanted it to look like a bunker. They didn't want to detract from the heritage of the building, given that it's already 50 years old. So those corridors were improved and ratings were enhanced. The bulk of the work happened just south of that, where we've got, I think it's a little bit more of a pink line, and it may be a little bit harder to see, but right at the bottom where we're coming out through the front into sort of just a little vestibule there, that would come out in the tunnel, and that was all wide open. So what we've done is divide that into 2 zones so that the exits are leading into opposite sides of that tunnel. We've put in 2 fire shutters that stay open. They're up on they're a rolling fire steel door, that will drop on fire alarm. And so those will keep the 2 paths separated. So the shutters are more aesthetically pleasing because they're not big chunky doors that are in your way. So what we have is a shutter in the tunnel, a shutter in by the main entrance, and 2 bidirectional fire doors in the middle so that if one path is contaminated by smoke, that the public has another option to go down the other path to get out of the building safely. In addition, we did fire alarm upgrades within the building. So fire alarm upgrades would have included replacing some of their old and deficient equipment. We improved the wiring. We added detection in the building. The sprinkler system was installed. It wasn't previously sprinklered. So what the sprinklers will do is they provided an automatic suppression within the building. It's an automatic fire response. The sprinklers are activated by heat. So once a sprinkler head detects a certain level of heat in the building, they will start to spray water on the fire. I always enjoy telling people that sprinklers are not like the movies. You do not set one off and the entire building soaks and it evacuates. Each sprinkler head goes off individually. So the fire suppression in this one was automatic. Part of the fire alarm upgrades, because these two sort of go in tandem, is that we've added smoke detection on those red corridors at the top level. And in our world, smoke detection is considered early warning, because a smoke detector will activate before a sprinkler will activate. And so we have more time to notify the occupants of a condition and give them direction in terms of what we want to do. The standpipe and hose system was upgraded, which is a manual fire suppression system. They did already have one in there. They did consider fire safety when they built the bunker because they needed to be in there for 30 days. That was the plan, that they weren't coming out. So they did have some of the equipment in there, but a lot of it had to be replaced and repaired and upgraded. And so what the standpipe system will do is allow a manual fire suppression system. It's hoses spread throughout the building that allows the occupants to manually suppress a fire if the sprinklers have not been able to control it. And originally that was the only system that was in there, so they had their own fire brigade that was responsible for doing that. The compartments would close and the idea was to contain, confine, and suppress. In addition to that, we upgraded the emergency lighting, so if there's a power outage or any of those types of natures, there's lighting that will guide the public through the building to the appropriate exits, being the vertical fire stairs up to the top to get them out. We added exit signage so that you can easily find your way around the building and find those exits. We added a new power generator to support it, to support all of the new systems that we were putting in. The water supplies had to be upgraded. They had three water tanks. I believe 2 were for fire. 1 was converted from potable to fire water, and the bladders in the 3 tanks, given their age, had to be replaced. Not an easy task when you're working below grade and loading everything in and out through a tunnel and through a couple of stairs. And there was, being a 50-year-old building, some asbestos that had to be removed. Some of the unique challenges that we may not consider working on a below-grade building was services don't work, cell phones don't work, mobile communication doesn't work. We are not used to working like that anymore. You have to go and find people in the building. Certainly, problem number 1 was creating a second exit. That was the original problem. They wanted more than 60 people in there, and we needed to get them out. Cutting through the concrete was not an option, so we had to find another way to do it. Just moving materials down the ramp and in and out was certainly one, and no municipal water supply, hence the tanks that are on site. So there was a number of things that went on in order to support the alternative solution and increase that load effectively from 60 to 420 people. So everything working together, a comprehensive report, 3 years of discussions with the authorities, a lot of brain power, a lot of time, and a lot of commitment. And it's sitting there. I encourage you all to go and visit. It's really cool. It's like stepping back in time when you go down there, but they're operating as a museum. And that's the bulk of my presentation.
My name is Elizabeth. I'm with the Pembroke chapter. And I was just wondering, is this a national building code site, or is it under the Ontario Building Code?
This one followed the Ontario Building Code.
Oh, so it's not a federal site then?
No, my understanding is no, it's not.
Oh, okay.
It's in Ontario. We did follow the Ontario Code.
Okay, and is it designated as a heritage site, do you know? Or this is just a question out of my head.
I believe that it is, but I'm not sure at what level. I know there's multiple levels of designation and they affect certain pieces, and I do know that they have some heritage plaques there. And I believe that they're in the process of trying to move it up the designation path, but it was certainly a site that the local community wanted to preserve. They didn't want to fill it with water and fill the tunnel and shut it down and let it die, which is what has basically happened to the other ones.
Right, and sorry, last, were there CO2 sensors installed there as well?
I don't believe there was.
Carbon monoxide, you know?
I don't know for sure. I would have to check the file, but I don't think so.
Okay, and
there's no vehicle exposure.
No